This third column is for molecular shape. Molecular shape depends entirely on the repulsion of regions of negative charge. It's a thing called VSEPR in chemistry, but you don't need to know this. VSEPR, which stands for valence shell electron pair repulsion, which is a fancy way of saying when you've got electrons in the bonds, hopefully you can see my little dot. If you've got electrons in the bonds between atoms, those electrons repel away from each other as far as they can in 3D space, which is why carbon dioxide forms that shape of a line, because the furthest place those electrons can get away from each other is opposite sides of the atom. So the molecular shape for carbon dioxide is linear because the bonding electrons between the carbons and the oxygens repel from each other because they're negative, regions of negative charge, repel from each other and make a linear shape. You don't need to know VSEPR, but you do need to know that shape depends entirely on repelling or repulsion of regions of negative charge, or electrons. So when we come down to the next one, you've now got 4 regions of negative charge. As well as the bonding electrons between the hydrogens and the oxygens, you've also got 2 regions of a couple of electrons above and below the oxygen in this picture. So these are going to repel away from each other in 3D space. In 2D space, this would be the shape, but in 3D space, it's going to be a bit different. And I'm going to show you that on here. You remember the 3D model that we had yesterday, which showed that 4 sticks in 3D space, when they push away from each other as far as possible, they form this sort of a shape? Well, water does actually sort of have 4 sticks, except that 2 of those sticks are not actually atoms. So it's got 4 regions, and those 4 regions push away from each other. But unlike this picture, 2 of them are actually just electrons that are unbonded. So it's actually more like this. So if this is water, which it's not, because there's way too many protons, but if this was a molecule like water, then you can see you've got a central atom, and you've got 2 atoms bonded to that, and then 2 extra regions, which are represented by black sticks. Those extra regions are all repelling from even the bonded electrons. That's why water forms what we call a V shape. So when I draw it on here, I draw it like this. Because it better represents what it actually does in 3D. It's not straight. I mean, if you looked at it from the end on, it looks straight now. But the reality is it's actually bent because the electrons that are the sticks above the atoms are pushing them downwards into a sort of a V shape. So the name for that is V-shaped. Ammonia is a bit more straightforward, but still follows the same principles. You look at all the regions of negative charge. This one has regions of negative charge, that is electrons, between the nitrogens and the hydrogens, and it's also got one above the nitrogen. So again, you've got 4 things repelling from each other, but one of them is not a bond. And so in 3D, this ends up looking like this. Like a pyramid. So instead of looking like a T, it ends up looking more like an M or a pyramid, because the 2 non-bonding electrons push the other ones away all in the same direction to form a sort of triangular pyramid shape. The name of this shape is trigonal pyramidal. Carbonate has 3 regions of negative charge. It's got the double bond on the left there, and it's also got a single bond to a negative and a single bond to a negative. So you've essentially got 3 regions of negative charge. So those 3 things are going to repel from each other as much as possible, which ends up forming this shape. Because that's the furthest they can get away from each other. It's actually flat, even in 3D. So it's called trigonal planar. Planar meaning it's flat, with 3 prongs going in different directions. Ammonium is a case of 4 regions of charge repelling each other, and in 3D space that forms a tetrahedron. So if we were to draw this one, in 3D it would look like this. And so we try and represent that. So there's 4 things that push away from each other in 3D space, and it sort of looks like that. So we represent it with an upper stick and 3 lower sticks pointing sort of to the side, and we end up with this sort of a shape. This is called tetrahedron. So the number one thing to remember from this is that molecular shape depends on repelling of regions of negative charge, which is repelling of bonds, because they consist of shared electrons, and non-bonding electrons as well, because they're also negative.